Hello everyone, welcome to my channel Chemical Engineering Knowledge. In the previous picture we have discussed about the interface mass transfer and the phase equilibrium. In this picture we will discuss another important topic related to the interface mass transfer, which is the degree of freedom analysis. Degree of freedom. Degree of freedom. Degree of freedom. The degree of freedom shows us the number of independent variables. Shows the number of independent variables to completely define a system. It shows the number of independent variables which completely define a system. The number of independent variables. These independent variables can be temperature, it can be pressure, it can be mole fraction. So these independent variables, it can be volume of a system, it can be density of a system. So let's show the degree of freedom. Actually the degree of freedom shows the number of independent variable. These independent variable can be 1, it can be 2, it can be 3. It depends on our system. So in some system we need one independent variable to completely define our system. In some cases we need two independent variables, temperature and pressure. In some cases we need 3 or 4 independent variables to completely define our system. So the degree of freedom shows the number of independent variables to completely define a system. So this is the degree of freedom analysis. Now what is the formula for the degree of freedom analysis? The formula for the degree of freedom analysis is C, which is F is equal to C minus P plus 2. And this equation shows the degree of freedom analysis. In this equation, C is the number of components. Number of components present in this system. P is the number of phases present in the system, and F is the number of independent variables, or the degree of freedom. Degree of freedom or number of independent variable. So in this equation, C minus P plus 2, the C is number of component. The number of component, the C can be number of component can be 2, it can be 3, it can be 1. Similarly, P is the number of phases. Phases can be 2 phases, it can be 1 phases, it can be 3 phases, it can be 4 phases. And F is the number of independent variable, which is obtained from this left hand side. So let's explain it with some example. Let's explain it with some examples. Suppose we have a system. Let's explain it with example. Suppose we have a system Suppose we have a system. Suppose we have a system in which the water is, suppose this is our system. There is some water present in it. There is some water is present in, it. And above the system there is air plus another gas like sulfur dioxide. Suppose we have a system in which water is present, and above the water there is some gases. Above the system there is some gases like the sulfur dioxide and air. We assume that air is not dissolving or air is not absorbing in the water. Only and only sulfur dioxide is absorbing in the water. Sulfur dioxide is absorbing in the water. We assume actually air is also absorbing in the water, but we assume that sulfur dioxide is absorbing in liquid water. So what will be the degree of freedom for this system? As we know that the degree of freedom is equal to C minus P plus 2. So in this example, how many components are present in the system? There are 3 components are present. Components are 3. How many components are present in the system? There are 3 components. One component is air, second component is sulfur dioxide, the third component is water. So one component is water, second component is air, and the third component is sulfur dioxide. We assume that the air is one component, but in reality air consists of nitrogen, oxygen, carbon dioxide, but we assume that air is only one component. Similarly, how many phases will be present in this system? So in this system there are 2 phases. One phase is the liquid phase. This is the liquid phase. And the second one is the gaseous phase. So 2 phases. One is gas phase. This is the gas phase. This is the liquid phase. So one is liquid plus gas. So P is equal to 2. One is gas phase, one is the liquid. So P is equal to 2 for this system. So what will be the degree of freedom for this whole system? So the degree of freedom for this system will be equal to 3 minus 2 plus 2. That is 3. So we need 3 independent variables to completely define this system. To completely define this system, we need 3 independent variables. When we determine these 3 independent variables, other variable will be obtained automatically, or we will obtain other variable by using equations. So if we know these 3 independent variables, we will define this system completely. There will be no problem in this system to completely define this system. So we need 3 independent variables to completely define this system. So we need 3 independent variables. Now what can be the 3 independent variables? Usually temperature. One independent variable is temperature, other is pressure, and the third one is mole fraction X, which is the mole fraction of sulfur dioxide in the water, or Y. So if we know the temperature, the pressure and mole fraction of sulfur dioxide in water or the mole fraction of sulfur dioxide in air, then we will define the other variable of this system. We will define the mole fraction of sulfur air in the gas phase. We will define the mole fraction of sulfur dioxide in the water and the mole fraction of water in the liquid phase by using a relation which shows that the sum of mole fraction is 1. So suppose mole fraction of sulfur dioxide in the water and mole fraction of water in the system is equal to 1. As we know that the sum of mole fraction is 1, or mole fraction of sulfur dioxide in the air plus mole fraction of air in the gaseous phase will be equal to 1. So if we know this mole fraction or this mole fraction, then these two mole fraction will be determined by using these equations. So for this, usually this temperature and pressure are easy to determine by using the temperature measuring instrument and the pressure measuring instrument. So for this system, we need 3 independent variables to completely define our system of air, sulfur dioxide and water. Also, for this system we need 3 independent variables. One is the temperature, one is pressure, and the other is mole fraction. And by using the equation that the sum of mole fraction is 1. The component A is for the sulfur dioxide, B is the water, suppose B is the water, and C is the air. A component is sulfur dioxide, B component is the water, and C component is the air. So in this case there are 3 components. 2 were the phases, liquid case, 3 were the component, A component, B component, and C component. 2 were the gases, liquid and gas, and this is the 2 of the equation. So these are 3 independent variables. One is temperature, one is pressure, one is the X or Y are needed to completely define our system of water and sulfur dioxide. So for this system we need only 3 independent variables. So similarly suppose we have a system. Suppose we have a system of water and this is the air. Air is absorbent in the water. Then how many independent variables will be needed to complete this system? So let's see, check it. This is equal to C minus P plus 2. Here the component is, suppose air is component A and water is component B. So here 2 components. The component is 2. C is equal to 2. Phases, one is the liquid phase and other is the gaseous phase. So phases is also 2. So component is 2, phases is 2 and 2. Again, for this system we needed only 2 independent variables. Suppose temperature and pressure. So if we know the temperature of this system, if we know pressure of this system, we will completely define this system. Usually temperature is room temperature. Suppose it is 25 degrees C and pressure is 1 atm. So if we know the pressure and temperature of this system, we will completely define this system. We can define the mole fraction of air in the water. We can define the mole fraction of water vapor in the air. So this is the simple examples related to the degree of freedom